Hello, everyone. Welcome to first period, Thursday, September 13th. All right, so let's read this one. Take a moment to read it to yourself. If you want to circle anything, highlight anything, feel free to. Do you guys remember what this part of the box is called? Do you remember what the min, the quartiles, the max, and the median, what this is called? It's from a couple chapters ago. Yeah. It's called the 5-number summary. Remember that? We use the 5-number summary to help us make some type of graphical display. Do you remember what type of graphical display that helped us make? Very good. The box plot, or the box and whisker plot. Either one, box plot or box and whisker plot. Okay, now it also gives us, now you see where it says X bar? I want you to cross that out and put Y bar. We're always going to use Y bar. And what does Y bar mean? What does the Y bar mean? It's the mean. It's the average. Ah, see what I did? Yeah, everyone at home say yes. So Y bar is the mean. Okay, what is S? What is S? The standard deviation. Why is it not mu and sigma? Because it's real data. Exactly, it's real data. Very good, Pablo. It's real data. I understand this is a worksheet and not real, but for our purposes, this is considered real data.
So real data is Y bar.
Very good. Model, not real data, or looking at what's going to happen in the future, is mu and sigma. But they mean the same thing. They always mean mean and standard deviation. But your notation is important. All right. It'll tell you something about they're going to use a normal model or assume a normal model when it's not real. Something about normal. It doesn't say anything about that it's a normal model. We just started. I mean, if it's an emergency, yeah, go ahead. You're going to miss it. Okay, great, thanks. All right. Now, it says, for this college, and I wish it was this cheap, guys, but it isn't. It says they charge $73 per credit hour, plus a fee, no matter how many hours you take, of $35 a quarter. Okay, so even if you take 3 hours, you still get charged that $35 fee. Okay, if you take 25 hours, still get charged $35 fee. Okay, now, if this is the mean, if 16.65, that's the average credit hours, what is the average fee that students are going to pay to go to school at this college for 1 quarter? So we know they're going to have what? The $35 fee no matter what, plus 73 times, very good, 0.65. Whatever that is, you can use your cell phone as a calculator. Should write this down, sure. Caesar, you write it down? Make sure you write it down. You're going to have to do this tomorrow for a grade. And on the quiz, it'll be like this. And what is the average fee that students pay to go to this college for a quarter? Anyone? Can anyone confirm that?
Yes.
All right. So we got $1,250.45. Thank you, Dino. Now, if you move to the right, where it says Roman numeral 2, what is the standard deviation for the fees paid? What do you think most students do when they move to number 2? What do you think most students do when they move to the next question about standard deviation? They do the same thing, but instead of 1665, they put in 2.96. Why is that wrong? Why would that be wrong? Because that's what, probably if I had you guys do it, you would have done that. Why would that be wrong? Because some of you are thinking, like, yeah, that makes sense. Remember from Tuesday, standard deviation is a measure of spread. it is not affected by adding or subtracting. So do you see this plus 35? Is it affected by that? No, it's only affected by the multiplying of 73. So the answer to number 2, or part 2, is going to be 73 times 2.96. And that will be our standard deviation for the amount they paid to go to this college per quarter. 216.08. Very good. So $216.08. Is everyone clear on why that work was different? I want to make sure you're clear, because you will have to do this tomorrow. I want to make sure you're all clear on this. All right. Now let's move to Roman numeral 3. It says, what is the median fee paid? What is the median fee? So what are we going to do for the median? What is median? It's a measure of center. So will it be affected by everything? Yes. So that gets the $35 plus $73 times, what was the median? 16. So whatever that is going to give us our median fee that was paid to go to this college per quarter. $1,203? All right. Now when we move to the IQR, that's a spread. So it's only going to get what? Multiplied by 73. Do you know the IQR? It's 4. How'd you get that, Alyssa?
19.
Hold on, Alyssa. And Gilberto, so what numbers did you use?
19 minus.
Very good, which is 4. Nice work. All right, what's 73 times 4? 280 plus 12. Very good. See what my brain did? I multiplied 70 times 4, got 280. 3 times 4 is 12. And we go. Cool trick there. You can multiply 70 times 4 is 280. 3 times 4 is 12. 280 plus 12 is 292. Fun little trick there. Math is amazing. Math is a wonderful thing. Absolutely, your cell phone. All right, everybody good with this so far? Great, let's move down to the last part. 28 credit hours seems like a lot. Would you consider the maximum of 28 credit hours to be unusually high? Why are you saying yes? Again, what word would you use right now? Because you haven't done any math. You're saying yes, but have you done any math? You could say, I mean, approximately is not the right word, but you're on the right track. What do we say when we think something? Not roughly. Remember we looked at it in histograms when there was like something really far in one direction. We said that was. We didn't say it was an outlier. We said it was a possible outlier. Do you remember that? Don't worry, they're going to come through the walls. Possible outlier. Remember that word? So those of you that are saying yes, how do you know? Have you done any math? No. And so when I give back your test later today, some of you are going to realize, oh, that's what you wanted me to do for that problem on the test.
For B, we would have to find outliers.
Yes, we need to find whether it's an outlier or not. If it's saying it's unusual, the way to test if something's unusual is to see if it's an outlier. If we say, yes, it's an outlier, then I know it's unusual. So what's the first thing I need to do in order to find the outlier? First, I actually need to find the IQR. We already found it. What was the IQR? 4. Then I multiply that times 1.5. So that's what you multiply by 1.5. What's 1.5 times 4? That's the number we're always going to use. When you go to stats in college, your teacher might use 2. So whatever your teacher tells you to use. Both are accepted in statistics. So what's 1.5 times 4? Oh, come on, guys. What's half of 4? What's half of 4 to 2 plus 4 is? 2 plus 4 is? 6. So the grand total number is 6. What am I going to do with 6?
Minus Q1.
Very good. So it'll be Q1 minus 6. And that's going to give us our lower fence. What am I going to do for the upper fence?
Plus 6.
With what? With Q1?
Q3.
Very good. The third quartile. What is quartile? So it's based on that. I believe quartile 1 was 15, right?
Yeah.
15 minus 6. I believe quartile 3 was 19. 19 plus 6.
What? Oh,
Yes, always add with the upper fence. So, are there any numbers that are to the side of those fences? Are there any numbers that are lower than 9 and above 25?
yeah.
28. So is 28 unusual? You would say yes, it is above my upper fence of 25. So it is an outlier. Very good. It's unusual. All right, Pablo?
No.
Say it again. If it's lower than the lower fence, if you had somebody taking 6 credit hours, what would you say about that student's credit hours? Also, an outlier. What was the minimum value? Minimum value is 5. Is 5 below 9? Yes, it didn't ask us in this problem, but is there at least another outlier? There is, that student that takes 5 credit hours, because it's below 9. Now again, you'll notice I heard at least. We have at least 1 in the high direction, 28. We have at least 1 in the low direction, 5. Could there be data values that are between 5 and 9 and between 28 and 25? Yes, I don't know if there are, but there could be. So that's why I say at least. All right, we have at least 2, 1 in the high direction, 1 in the low direction. There could be more. I don't have all the data. All right? I didn't count you off on that on the test, but that's definitely something that as you get better and better at stats, you'll be thinking about, well, I don't know if there's more, but I know there's at least this one. Okay? Any questions on this whole problem? Again, you will be asked to do this tomorrow for a grade.
What did you do 1.5?
Why did I use 1.5? Remember, Dina? That's the number we use in this class. You might do another stats class in college where the teacher will tell you to use 2. Both are acceptable in calculations and statistics for determining outliers. All right? If you use computer programs like Excel or other things, they might use different numbers. Excel uses 1.5, but some other programs use different numbers. All right? Excellent. Let's go to number 2. Number 2. Now, this Wechsler Adult Intelligence Scale, revised, follows a normal model with a mean of 100 and a standard deviation of 15. You'll notice they're telling us, Gilberto, you've asked about this, right? They're telling us it follows a normal model. So we know we're going to use what for our notation? No. It's a model. So we're going to use what? Mu and sigma. So you'll notice I wrote a capital N. What does the capital N stand for? Normal model. And then the next things that come after it are the mean and the standard deviation, where I use the notation mu and sigma. All right, that's the notation. Those are called the parameters of the model. I'll write that down. The parameters of the model. That's what these are.
So this is normal model, that's
Mu and sigma. Very good. Now, what is mu? What is the mean? 100. Well, let's just say points because I don't really know what it's out of. Okay, 100 points is the average. What is the standard deviation for this intelligence score? 15. So when I draw my normal model, you'll remember on Tuesday that I drew 1 right down the middle. Then I had 1, 2, 3 above, and 1, 2, 3 below. And why do I care about going 3 standard deviations above and 3 standard deviations below? Do you remember that rule from Tuesday? It's called the 68, 95, 99.7 rule. Basically, Giuseppe, your brain is on the right track. The idea is if anybody scores a score on this that's not inside what we write here, then we would consider their score unusual. Okay? All right. So the mean is 100. If I go to the right, 1 standard deviation, what would that score be? 1 to the right. 115. Let me see how I got that. Go another standard deviation. 130. And finally, 145. If I go the other direction, 100 minus 15. 85. 85 minus 15. 70 minus 15. 55. So what we're saying is, if your score is not in between 55 and 145, your score is unusual. Will those scores happen? Yes, they will. Are they likely to happen? No, they're not likely to happen. Now, it doesn't tell us what the maximum score is. So I don't actually know. That would be helpful for me. Like if the max score was 150 and the min score was 50, that would give me more idea of what's going on here. Okay? So again, the idea is we expect 68% of the people taking this test to score between 85 and 115. We expect 95% of the people taking this test to score between 70 and 130. And we expect 99.7% of people taking this test to score between 55 and 145. And 99.7 is almost everyone. Okay? So we're expecting everyone to be within 145 to 55. Any questions on the normal model here? No questions?
So,
Yes.
what that, where's the fact that it's
Yes, Gilberto's right. If you're moving to the left, you're subtracting the standard deviation. If you're going to the right, you're adding the standard deviation. All right, let me see if your brain has this connected. Do you remember? Sorry, Gilberto, yeah.
why you start from
Why did I start from 100? Why did I start from 100?
why you start?
Yes, always going to be 3 above and 3 below. Let me ask your brain this from yesterday. Remember when we found z-scores yesterday? What would the z-score be for 115? You should know it without doing any math.
What happened?
I'm asking what's the z-score of 115 without doing any of the math? What is it? No? It's 1. Because 115 is 1 standard deviation above.
So if we were to go to 130, it'd be 2?
And then the other way? The idea is if your z-score is past 3 or negative 3, it's unusual. All right? Remember that? I was trying to link that to yesterday when we found z-scores. All right? Okay, let's keep working with z-scores. Let's come in on this next problem. Let's flip it over to the back side. Almost there, guys, and then I'll be done. Just 5 more minutes. All right. Number 3. Yay, dogs! Okay, puppies! There's this really, really cute black lab that is on Thrush every morning and every afternoon when I leave school. One of these days, I'm just going to be like, do you want a home? I mean, it's the most adorable dog. Have you seen it? It's just on Thrush. Every morning, every afternoon, it's right there. It's gone. I just saw it this morning. Yeah, a black lab. Like a skinny one. It clearly hasn't eaten much. I think it's a stray. I think he stays there because he's trying to get food from people. Black one. Yeah. It's not really big. It's probably like, if it was full weight, it'd probably be about 60 pounds. But since it looks like he hasn't eaten much, probably like 40 pounds, 35 pounds.
Oh, I know what you're talking about.
He lives laying right there on the street at like 7:45 this morning. Yeah, because you want food. Huh? I'm not going to. If I didn't have a dog, I would, but we have a dog. And our dog isn't the... You have 3 dogs? Too much yet. Come on, thing. All right, here we go. Last one. Nice, you do? Awesome. So, in this problem, we have 2 breeds. You guys see we have 2 breeds. We have Dalmatians and we have Boxers, and they're both female. And they give us weights for 2 dogs. 1 female Dalmatian and 1 female Boxer. And we want to know which dog is more underweight. Now, you might just think, okay, well, what is the weight of our Dalmatian? No, what is the weight of this actual Dalmatian that we're looking at? 45 pounds. You see that? They're saying this Dalmatian is 45 pounds. And what about the female Boxer? 52. Now, you might just be thinking, well, clearly it's the Dalmatian is more underweight because she weighs less. But again, because they're different breeds, what should we do first before we compare them? The z-scores. What's that called when we find z-scores? That's called standardizing. Standardizing. It takes out the units, guys. It takes out the units. Now, Gilberto, here we go. This is your question every time. What notation am I going to use when I write down the formula? Z equals y minus y bar. Why did we write y bar? Because it's real dogs. Okay? I know that's why I'm always using the air quotes. It's not really, but in this purpose, this is a real dog we're looking at. Over S. So let's do it for the Dalmatian first. All right? So Z equals, how much does our Dalmatian weigh? 45. What's the average weight for female Dalmatians? 50. And the standard deviation? 3.3. What about for the boxer? How much does our female boxer weigh? 52. What's the average weight of female boxers? Very good. And the standard deviation? 1.7. So we can find our z-scores and compare them. So do the calculations. See if we get enough people to confirm the same answer. Then we'll feel good before moving on. Go ahead. Yeah, remember we always do your data value minus the mean divided by standard deviation every time.
The mean is the average.
The mean is the average. Alyssa, did you get anything?
For
What?
Dalmatian?
Yeah, for Dalmatian.
29.85.
29.85? No, you're good. It should be negative 5 divided by 3.3.
70?
Negative 5 divided by 3.3. You're good. Yeah, because 18 is wrong.
29.8.
How are we getting 29?
We're adding it, like, we have to do it separately.
Yeah, you got to do it separately, guys. I'm sorry if you're not using parentheses. That might sound more, it's negative 5 negative divided by 3.3. So no, it should be, here we go. There we go. Negative 1.5 exactly? 5.1 what? Thank you. Negative 5.1. Oh, it's repeats. Okay, so let's do negative 1.52. Did everybody finally get that?
Yeah.
Okay, cool. What about for the boxer?
Negative 3.24.
Negative 3.2. Is it rounded to 4? Okay, so remember when we said the Dalmatian weighed less? Well, what happened when we standardized based on their breeds? Who actually now we should be worried about because they're unusually underweight? The boxer. See how the boxer is past negative 3? Negative 3.24 is below negative 3. So we would tell that owner, you should take that dog to the vet and see if everything's okay, because I'm not joking here, that is past what we would expect a female boxer to weigh. All right, now maybe there's something going on. Maybe it's a mix of another breed, so it makes it smaller. I don't know. All right, that's why you would go to the vet. Maybe something's up. Any questions on this? So again, did you see me write anything? Like write a sentence. Did you see me write a sentence? What are you going to do tomorrow, though? Write a sentence. You need to say that the boxer is more underweight because they have a lower z-score than the female Dalmatian. I'm looking for something like that. You don't have to go far. Remember when I said like they should take him to the vet because it's unusual? You don't have to say that. But I am expecting you to say the boxer is more underweight because the boxer has a lower z-score than the female Dalmatian. I'll say it again. The female boxer has a lower z-score than the female Dalmatian. So that's why the boxer is more underweight. It's not real, right? It's real. All right, guys. Nice work. So we're going to stop here. You're not expected to do number 4.